Okay, now, you know that if 2 to the A equals C, it's equivalent to log base 2 of C equals A. Okay? So what do you think B to the A equals C would be equivalent to? Well, what's the difference between B to the A equals C and 2 to the A equals C? Go back to Sesame Street. One of these things is not like the other. Okay? What's the difference?
You added the B.
We didn't add it, we replaced 2 with it, but that was a good answer. Okay? Yeah, there's a B here, well, there was a 2 here, right? Well, what do you think we're going to do with this?
Log BC equals A.
I'm sorry, again, batteries are dead.
Log B equals.
Yeah, yeah. And you're going to say it right. You know, and we're going to replace 2 by B, we're going to replace 2 by B. Okay? Works for any positive B. If you had a negative B, none of it would make any sense. We don't even worry about it. Okay? Makes no sense if you have a negative B. I mean, at least this equivalence makes no sense. You can't do a log for negative B because you know by inverting the graph of the exponential function, you get the graph of the log function, and a domain doesn't even include negative numbers because the value of the exponential function can't ever be negative. And hopefully you know that from doing the graphs. Okay? If you don't, just accept my word for it. Maybe give it a little thought. Okay, so all of a sudden, we could solve 0.7 to the x equals 12. Okay? How do we solve that? Well, I mean, y'all seemed to be pretty good, at least a week ago when you took the test, at using this rule. And this rule's just like it. It's exactly the same, except you could use any number instead of 2. Okay? So this is equivalent to log base 0.7 of 12 equals x. Okay? So I just write it in the other form, but how are you going to get log base 7 of 12? You're going to use your calculator, obviously. Okay? You'd have to take about 3 successively tougher math courses before you'd even have a clue how to do it otherwise. Okay? And it's totally pointless. Nobody does it. Except when you're studying calculus, so you learn how to do approximations. And that's important. But the practical use for solving an equation like this, it's not practical. It's already been programmed into your calculator. Okay? A lot of work for nothing. So, you do this. What's the rule? What's log base 7 of 12? How are you going to get that? If it's log base 2 of 12, what would you do?
The log of 2 times the log of 12.
I think you said that right, but maybe backwards. But it's you do log of 12 divided by log of 2. So log of this divided by the log of this. Well, in this case, log of 12 over the log of 0.7. Okay? And you plug that into your calculator. Anybody got a calculator handy? I think you're going to get something like -4. And a little more than that, but it won't be as much as -5.
I got -6.9.
-6.9,
Yeah, that's what I got too.
you're going to have to check out those calculators. Disagreed with what I thought. Couldn't be right. Oh, yeah. Okay, yeah, it is. Never mind. I squared 0.49 and got 0.16 because of the 0.4. It's close to 0.25. Anyhow, okay. So it's approximately equal to 6. Okay? Well, that was easy. We just did something that you've
-6.
done very similarly, except the base isn't 2 anymore, right? Okay? Yeah, of course, you can solve logarithmic equations. If we have the equation log base 3 of 5 of x equals 5, we change that to 3 to the 5th equals x, and you don't even need a calculator for that. Okay? That was 5.3, you'd need a calculator, but so x equals 240. Uh-oh, wait, that's the 4th power. 5th power is going to be 900 and 120, 1,029, I think. Okay? You can check out in your calculator. Have a good laugh if I'm wrong. Happen too often. It's 1209. No, 1,000.
Mine says
209.
243.
Wait. 343. You got 343. 1, 2. Yeah, you're right. That's what I said first. Okay? I was busy multiplying 343 by 3.
243, not 343.
Huh?
243.
Like I say, you should know your powers. Okay. Okay, it's 243. 81 times 3. 80 times 3 is 240. 340. So, another lesson, don't write things down without thinking. Okay, I pretend to do that a lot, so you'll not do it yourselves, right? Yeah. Okay, 243. Anyhow, you understand what to do, right? You understand that's just the flip side of this. It's the same rule. Well, we're using actually this rule here. Okay? So any problem with that? Shouldn't be. And with compound interest, you get things like this, right? How do you solve that equation?
Divide by 1,000.
Yeah, divide both sides by $1,000. Okay, and you get 1.06 to the t equals 3. So t equals log base 1.06 of 3 equals log of 3 over the log of 1.06. Okay? And I'm guessing that's probably going to be like 16 or so, 17. I'm going to guess 17. Okay? There's a simple rule I used to do that. I didn't do any profound calculation, just a little rule of 72 and a little interpolation. Okay? So nothing mysterious about how I got that. Was it close?
18.9.
16.9?
18.
Huh?
18.
18.9. Yeah, bring a bunch of broken calculators to this class. Get some good ones. Okay, so it's 19. That's what I meant. Okay. Understand how to solve these equations. Now they get harder. There's some rules that we got to use. Because if I ask you to do this, for some reason, that wouldn't necessarily be related to compound interest. But what if I ask you to do let's just use log base 2, but any log could do, of if I gave you that equation? Well, I would not expect anybody to have a clue. Although some of you might have, because I don't know what courses you had previous to this. Okay? There's a rule for when you add logs. Okay? And the rule is very simply this. Okay? Log of A times B is a log of A plus a log of B. Simple rule. Just like the rules for exponents. Okay? You know when you multiply e to the x times e to the y, you get e to the x plus y, right? Now you should know that. Okay? And this is just kind of the reverse. Here you got an addition that comes from multiplication. There you got a addition that comes from multiplication, but kind of in the opposite way. Okay, so anyhow, that's your rule. So how would you write this? How would you rewrite this using this rule?
The log of 2 times x squared plus 5.
Well, don't try to. You got to use the distributive law to do what you're trying to do. Okay. But what's A? Okay. This is, and this is for any base as long as it's the same. Got to be the same base. This is log base 2 of A. Plus log base 2 of B. For A equals x plus 3, B equals x minus 2, right? Okay? I mean, it's just this. It's a log of something plus a log of something, same base. So this is okay? And I'm out of board space, which happens too often. But I can come over here just use a little box here. This tells us that log base 3 of x plus 3 times x minus 2 equals 1. You see, the left-hand side is the same as this because of this rule. The right-hand side is 1. Well, we can rewrite that as 2 to the 1 equals x plus 3 times x minus 2. And that's an easy equation to solve. So how do you solve it? Well, first thing you do is use distributive law over here. Of course, 2 to the 1 is just 2. If you use the distributive law, you get x squared plus x minus 6. So 2 equals x squared plus x minus 6. How do you solve that? You're going to have some equations to solve over the weekend, okay? You're going to have x squared plus x minus 8 equals 0. Subtract 2 from both sides and then use a quadratic formula. So that x equals -1 plus or minus the square root of 1 plus 32 over 2, etc. And then you take your calculator and you approximate that. Okay? The point is, two things. You got to recognize when you have a quadratic equation. I'm going to give you a bunch of equations. Some will be quadratic, some won't. Some will be linear. Okay? If it's quadratic, and you recognize this is quadratic because you know when you multiply it out, you're going to get an x squared, right? So you multiply it out correctly using distributive law. I didn't write down the steps. I didn't have room, and we've done it many times. I want to see the distributive law. I don't want to see magic. Okay? Although if I do see magic and it's right, won't be full credit, but I'll ding you a little bit. Okay, but I'm mostly accepting. I want to see the distributive law. Okay, so anyhow, you get this, and you recognize, okay, this is definitely a quadratic equation. I got to put it in the form ax squared plus bx plus c equals 0, so that I can use the quadratic formula. Unless you happen to see an easy way to factor it. Okay? Yeah, that's unusual that things come out actually factored, except in contrived problems. Okay, so anyhow, there you have it. So now I'm going to expect you to be able to do this. I'll probably give you a little synopsis. I'll give you that rule. Okay? And there's one other rule I'm probably going to give you. See if you can figure out how to apply it. Okay? Kind of similar to this one. And you'll learn it better if you figure it out. But if you don't, we'll correct that next time. Okay. So there's that.